Thanks for inviting me to hold this talk. I have to say I am a biologist working in the built environment, and when I prepared this presentation, I was told that I should focus on practitioners. I would like to know how many of you are practitioners here? 15, 20%? Okay, that's good, not bad. Microbial sampling in building surveys, what and why are we sampling? Let me start with the second question. Why are we sampling in buildings? I think there are two reasons. Scientists want to know what kind of microbes you find in the building and what they are doing there, while practitioners have to answer to this question, why is my house killing me? I mean, occupant complaints. So here we are in the target room. We are going to start sampling. Where do we start? And in the last years and a few talks before mine, we have been told about the good sides of DNA sampling, so cheap, so quick, so efficient, and so on. And then the only thing you have to do is to go and swab around or swipe around, and then you get your answer. What concerns me is that many people forget that the building is more than the surfaces we see. There's a lot of building material between this wall and the exterior air. And these walls can look like that. There are also normally wet constructions in buildings, like drains, for example. And you have rooms underneath which don't look exactly like the rooms you are sampling from. And then you also have the ventilation rooms where all the air is being moved and transported on what was working and growing there. And why is this important? It's been said before, air leakage is very common. I mean, through water pipes, through electrical outlets, there is always air moving around and contributing with microbes to the surfaces you are sampling. So my first message, go beyond surfaces. And you're gonna hear me say that several times. I'm going to answer now to what are we sampling? And I'm going to tell you about my experience. I'm a mycologist, and in this case, we're going to focus on molds. And what we do is just to take a transparent tape, which we attach to the discoloration or the target substrate, and then we look in the microscope. After all, microbes are microscopic organisms, so you have to use the microscope. And this is going to give you a key on the condition of the surface. Sometimes, and if you take samples here in this room, this is what you're gonna get, what shows up in buildings. And you have a mixture of particles. Some of them are coming from the users, like these skin cells, and some of them are coming from the outside, like sand particles. And of course, you have material matter too. In other cases, what we get is this, what grows in the building. And here you can see the fungus active, producing spores and chemicals. And if I want you to remember something from this talk today, is the huge difference which is between this surface and this surface. Here we have inert microbes. They are not growing, they are dormant, or they are dead. By several reasons, usually because the air in buildings is very dry, and the surfaces are also very dry, unless the ones we see. But here, the story is different. This is a machinery of spore and chemical production. This is where things are happening. This is active ecology. You cannot call this a microbial community in the ecological sense of the word. This is where the things are going to happen. And because of this, those response to allergens and so on, this is what I think we have to focus. And for those saying that cultural methods are obsolete and not good at all, I can tell you with that tape, you don't even need to grow the fungus. The building is its own growing medium. So this is what we call a sink, and this is what we call a source. And we have to focus on sources. So where is the enemy hiding? I borrowed or stolen this slide from the Sweden Technological Institute showing 5 pieces of wooden materials with extensive mold growth. This is another reason why we have to sample. As you can see, there are some, in some cases, we cannot see the growth. And another thing I want you to remember, hello, here. In order to have microbial growth, and we are talking growth, you have to have a relative humidity of above 75% on the top of the surface, not in the middle of the room, or a water activity of 0.75 in the substrate. This is important. So does anybody know this fungus here? It was shown yesterday too. This is the dry rot fungus. Again, we have to come with a microscope and look how this is looking like. And we take a tape and see that this is only spore accumulation. This is a dormant fungus here. If you clean and disinfect this surface, at the next moisture damage is going to look the same. So this is a sink. Where is the source? And then it's where biologists come into the picture here. And we know what are the abiotical factors that makes this fungus grow within the building. We can also say which fungi grow in the building and which ones don't grow in the building. So knowing the substrate, the temperature, the relative humidity, and other factors, we can find the source in the building. And it's usually hidden in structures, as Mia and others have said. So to me, the experienced practitioner should focus on visual surveys, always looking for the source, sampling, we've been talking about why, also moisture methods, because of course you are not going to destroy the whole building looking for the source, and also technical surveys. Why are technical surveys important? This is a seal in an old house in Norway, which has been attacked by a beetle called the old house borer. And you can recognize it by the oval holes that the adults leave when they leave the wooden substrate. It's easy to identify visually, DNA, microscopy, everything. But if you only concentrate on the surface, you're going to lose the main problem in this building, which in this case is a wood rotting fungus. So go beyond surfaces. This is my main message. And I want to illustrate the dual happening in a good building survey. I want to show this beautiful picture of an old village in Norway. Building physics, of course, is important when doing building surveys, microbial building surveys. You have to know the buildings, have to know the difference among the buildings, you have to know air dynamics and substrates, but you also have to know the building biology. Now, something else, as Christian has said, biologists can read mold damage. And by looking at the fungi that grow in the building, you can see what kind of moisture damage do you have. The first ones that come into the building as relative humidity rises are Penicillium aspergillus, penicillium growing in colder places. And then if you have condensation, you have growth of Eulocladium, acremonium, or cladosporium. In case of leakages, you usually get Verticillium, Trichoderma, and Stachybotrys. Cold surface water available, and then even a continuous condensation for Stachybotrys. I haven't talked about air samplings, But I agree completely with Christian when he says that just one single spore captured from cultural medium in an air sample will almost make me to open a wall in a bathroom. Because we know that this fungus, the spores of this fungus, are only viable about 5 to 10% of the spores. And then we know that it loves gypsum boards, and it needs leakage to grow. So by knowing the ecology of the fungi, you're going to find your moisture source. And even then, my last message to you is be always, always open for surprises. Thank you.